Let us now understand steps to sketch inverse transform trigonometric functions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand how do we sketch the graph of inverse trigonometric function. We'll take three examples. So we have arc sine x, arc sine x plus 1, and minus 2 times arc sine x. So we'll first see how do we sketch the graph of sine inverse x, and then how do we transform it. X plus 1 gives us horizontal translation 1 unit left, and minus 2 arc sine x gives us vertical stretch by a factor of 2 and reflection on the x-axis. So let's figure out arc sine x or sine inverse x first. As you know, the sine function is a periodic function. So basically, if I draw a sine graph, which kind of looks like this, a horizontal line drawn will pass through more than one point. And therefore, we know that the inverse of sine is not a function. Now, to ensure that inverse is a function, and the whole range of sine is also taken care of, what we do is take a part of it. So let's take the sine function right there, right? So what we do here is just take the portion which is from minus pi by 2 to plus pi by 2. So in that case, we have the complete range of the function, which is from minus 1 to 1. And this part, which is between minus pi by 2 to pi by 2 as the domain, and range as minus 1 to 1, will have inverse as a function. So what we have taken here is sine x, where the domain is between minus pi by 2 to pi by 2, and the range is from minus 1 to 1. As you can see, sine x is always increasing. So that's the graph of y equals to sine x, correct? Which you are very familiar with. The only thing we have done now is restricted the domain from minus pi by 2 to pi by 2 so that the inverse is a function. Perfect. Now, the idea is how do we sketch the graph of inverse function? Now, inverse really means that x and y will swap. So the domain becomes a range and range becomes domain. So now, if I have a function y equals to arc sine x, the inverse, in that case, what will be the domain for this? And what will be the range for this? Well, as you know, the domain and range will swap. So the range of sine x will become the domain, so it will be from minus 1 to 1. And the range will be what was the domain of sine x, which is from minus pi by 2 to pi by 2. Is that clear to you? So those are the domain and range for the function. And the inverse will also be always increasing, right? Since you see that the function is increasing. Perfect. So now, to sketch a good graph, what we should do is take some values. So let us, we know the extreme values, of course. So what we will do here is we'll take some values between minus pi by 2 to pi. So just to make it simple, for the sine x, we could take the value, the minimum being minus pi by 2 minus 1, then we have 0, 0, and at pi by 2 we have 1. Correct. Well, I've also taken the unit circle here, and you'll see we are considering from minus pi by 2 to pi by 2. And all these values, the y values here, could be the points on the graph of sine inverse x. Swap them and get the points, correct? Now, arc sine x or sine inverse x points will be, you need to swap them, right? So it'll be minus 1 minus pi by 2, correct? 0, 0 will be invariant, remains same, and that will become 1 to pi by 2. So these will be our points on arc sine x or sine inverse x. So as you can see from this particular graph, what really happens is that the point which is at minus pi by 2, 1 now becomes minus 1 minus pi by 2. Now when I say pi by 2, it is 1.57, right? More than 1.5 times, right? So, so now let us plot these points. So minus 1 minus pi by 2 will be kind of here, right? Minus 1 minus pi by 2. 0, 0 remains there itself. And 1 pi by 2 will be, let's approximately put it there, correct? So the graph will become kind of like this. You see that? So that is going to be the graph of sine inverse x. But the idea here is to understand what exact points will be as shown here. And as you can see, the graph of arc sine x will be from minus 1 minus pi by 2 to 1 pi by 2 and always increasing. Now, let's move on to a fresh page. So what I've done here is shown accurate graph of sine inverse x. So the sine function has been shown in the dotted line, and then a bold blue line gives you the sine function. The inverse sine x is right there for you. So that is the minimum minus 1 pi by 2 minus pi by 2 and plus 1 plus pi by 2. So you can see the graph, it is going upwards, and the red solid line is the graph of sine inverse x or arc sine x. So we've done the first part, which is how do we sketch the graph of arc sine x. And now we'll consider the graph of sine x plus 1. So if I look into the graph of arc sine x plus 1, then basically the points of arc sine x will actually get transformed, right? And the transformation is to move each point 1 unit left, right? So let's write down the points. Sine of x plus 1. So the points were minus 1 minus pi by 2, 0, 0, and 1 pi by 2. Transformation here is that the xy point will change, x will become x minus 1, y will remain same. So the points will be minus 2 minus pi by 2, minus 1, 0, and 0 pi by 2. So basically, each point is translated 1 unit left, right? So that was 1 unit. So it is going to go 1 more unit left. So that is our new point. You get the idea? So I'm going to translate each point 1 unit left. To get the graph of sine, arcsin x plus 1, right? So, and we'll maintain the same shape, right? So we'll maintain the same shape, correct, like this. So that becomes the graph. So that is the y-intercept at the end, right? For the function arcsin x plus 1. And the coordinate points are given to you. You can see that the domain shifts 1 unit left. Is that clear? So, getting the new points using the transformation is always a good idea. Now let's look into the third graph, which is 2 arc sine x. So once again, we'll write down the points for sine inverse x. So arc sine and sine inverse x, one and the same thing. So minus 1 minus pi by 2, 0, 0, and 1 pi by 2. So we are considering these 3 points for our transformations. And we have minus 2 sine inverse x. So here the transformation is vertically stretched by a factor of 2 and reflected on x-axis. So the x values remain same, right? So the transformation is the xy points will now change to what? X being same, y will be minus 2 times y values. So let's put the x values same, right? And the y values will be multiplied by 2, minus 2. So this will become pi, and then here remain 0, and here it will be minus 2 pi. 2 and 2 cancel, negative sign, correct? So at minus 1, this time we have a value which is pi, right? So this point here at minus 1 will shift twice down below, right? So this will come here. 0 remains at 0 itself, and the top point is also vertically stretched, and it goes double the 2 pi, right? So that is the stretch part, and then we are going to reflect it. So once you reflect, so this value at minus 1 will now be shown that side, correct? 0 remains there after reflection, and the third point, which was the maximum, now becomes the minimum, correct? So the graph will be now like this. You see that? So that is how the graph of minus 2 arc sine x will be. So it gets reflected, and this function will be always decreasing, as shown here. Perfect. So that is how we could actually sketch the transform functions from the function itself using the old concepts which we know about. Important thing is to remember how do we sketch sine inverse x. So with that, I hope you have understood the concepts. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. You can always attend my classes by sending an email to globalmathinstitute@gmail.com. Thanks for your time and all the best.